Alright, hello and welcome back everybody. So today we're going to be talking about equations and inequalities involving absolute value. So we're just going to get started with the examples. So our first example is absolute value of x plus 2 is equal to 5. So just to recap, I'm pretty sure I just discussed this in a previous video, but these symbols, these long bars, they basically mean that if you have negative 6, it equals 6, and if you have positive 6, it also equals 6. So in this, we have x plus 2 is equal to 5, and x plus 2 is equal to negative 5. We have it equal to negative 5 because if we have negative 5 and then we have absolute value around it, then it would just turn into our result, and then 5 because we need it to equal 5. So for this one, for the top one, we have x equals 5 minus 2, which is 3, and then for this one we have x equals negative 5 minus 2, which is equal to negative 7. And if we plug both of them in, which we can see right here, negative 7 plus 2 equals 5. Negative 7 plus 2 is negative 5. Absolute value around it means that it equals 5. And then you do the same thing with 3, and you're going to get 5. Okay, so our next example is 2x plus 5 minus 3 equals 8. Okay, so now we can, since the 3 is not in the absolute value, we can just add 3 to both sides so that we can eliminate it, which means we're going to get absolute value of 2x plus 5, which is equal to 11. So we want 2x plus 5, 2x plus 5 to equal 11, and 2x plus 5 to equal negative 11. For this one, we have 2x equals, what, 7? No, not 7, 6. So then x equals positive 3. And then in this one, we have 2x equals 16, negative 16, which is equal to, so then x equals 8, negative 8. Wow. Alright, negative 8. And then when we plug it in, we're going to get 8. So negative 8 times 2 is negative 16. Negative 16 plus 5 is negative 11. And then you do the absolute value, which brings it to positive 11. And then 11 minus 3 is 8. And then 3 times 2 is 6. 6 plus 5 is 11. 11 minus 3 is 8. Okay, so our next example, we have the absolute value of 3x minus 1, and it has to be less than 8. Okay, so here's what we can do. We can do negative 8 is less than 3x minus 1, which is less than 8. Or you could just do 3x minus 1 is greater than negative 8, and wow, that's a pretty weird 8. And then 3x minus 1 is less than 8. And then you could just solve for x, I guess. So we're going to do add 1 to both sides. We get negative 7 is less than 3x, which is less than 9. So then you get negative 7 over 3 is less than x, which is less than 3. So then when we graph our solution set, which we can draw a number line here, 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Can use this line, the red one. Click. We are having some technical difficulties here. Okay, whatever. Seems like my computer is being very slow right now. Okay, anyway, we'll just use black. Let's see here. Alright, so we're going to graph it. So we know that negative 7/3 is in between 2 and 3, but it is closer to 2. So then we're going to just do that. And then we have positive 3, which we can do that. And then we can just draw a line. Remember, you can do parentheses or open dot when it comes to the less than signs. Okay, I still can't switch, whatever. Okay, so next example, isn't it the same one? No, okay, I guess not. So we have x minus 1 absolute value is greater than 3. So we also have to graph the solution on this one as well. So we have we can do the same thing as above with the with this, or we can do something else, which is, actually I already showed you. We can do x minus 1 is less than or equal to 3, and then, or x minus 1 is greater than 3, and then you solve both at the same time. Add 1 to both sides, and you get x is less than what, 2, negative 2, or x is greater than 4. So then you would just graph it on a number line. So we have 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, and negative 4. Can I switch to a highlighter or something? No, I guess not. Okay, so we're going to do this. Okay, so it's not a equal to sign. There's no bar underneath the sign for greater than or less than, which means that it's just going to be parentheses again. That's not very accurate. It's not on the 2. There we go. And then it's just going to be like that. And that should be it for this problem. Yes, it is. I did not click on the Windows button. There we go. Okay. Example 5. So we have 3x minus 1 in absolute value, and then plus 4 is greater than 6. Okay, and this is going to be our last example. So we can subtract 4. Oh, well, no, first we have to do the, what's it called? Oh, right, never mind. Okay, so yes, we have to simplify it first. So we have 3x minus 1 in absolute value is greater than 6 minus 4, which is 2. Now we can do what we did in example 4. We have 3x minus 1 is less than negative 2, and then 3x minus 1 is greater than 2. So we have 3x is less than what, negative 1. So x is less than negative 1/3. And then I forgot to put the or, and then or again. And then we have 3x is greater than 3. So then x is greater than 1. I think that is right. Yeah, okay. So then let's graph it. 0, 1, 2, 3, negative 1, negative 2, negative 3. Oh, that's a really weird 3. Anyway, let's see here. So we can do the 1 easily with the arrow, and then we can do 1/3. No, that's more like half. That's closer to 1/3, and then we have an arrow. I'm just gonna draw it above a little bit, that way you guys can see. But anyway, that is it for that problem. It goes all the way to negative infinity, and then this goes to positive infinity. So that is it for this one. And a recap on interval notation. I guess we can do that in this problem as well. It would be negative infinity, comma, negative 1/3, parentheses, because it is not less than equal to or greater than equal to, union 1, comma, infinity. And that is it. Thanks for watching, guys. I hope you enjoyed this video. If not, I'm sorry. But anyway, if you need any help, don't hesitate to contact me at this email. Otherwise, thanks for watching and have a great day.